Hi everyone, welcome back. Very good evening to you all. Myself Ayush Tripathi, mentor and problem setter at Geeks, and welcome you all to this post analysis of last Wizard contest. So let me check if everything is working fine. Can someone just please confirm if I am audible and visible? So let me check if everything is working. All right, so yeah, everything seems good to me. Let me just share my screen first. So starting with the easiest problem first. Which is the unique largest element. So given an array AR of size n, and you have to find if any element in this array is strictly greater than all other elements. And if that element, if any such element is present, then we have to return 1, otherwise 0, right? And if the size of the array is 1, then we have to return 1. So yeah, so how we can solve this problem? It's very simple. We have to first sort the array, and if the last two elements are same, then we have to return 0, otherwise 1, right? So it's very simple. We have to first sort the array, and let me clear everything from here. All right. So we are given an array of size n. So let's say a1, a2, a3, and so on till a of n. And we need to check if there exists some element such that ai, such element ai is greater than all other elements. All other elements. And if that is the case, then we have to return true, otherwise false. So in that case, we have to return 1, otherwise false, right? So hope the problem statement is clear to everyone. Let me give you some example here. So let's say 1, 2, 2, and 4, right? So in this case, this 4 is greater than all other elements. So in this case, our answer will be 1. We return 1. And let's consider this case 1, 3, 3, then 2. So in this case, the maximum element is 3, but we have two occurrences of the maximum element. So no such element is there which is greater than all other elements. So in this case, we return 0. And there is a base case if there is one element. So in that case, we have to return 1. So as it is mentioned in the problem statement, this one. if the size of the array is 1, then you have to return 1. So first of all, we want the maximum element. So for that, what we can do, we can sort this array. So sort AR using the inbuilt sorting function. Then AR plus 1. Now we have the sorted array and we know the last element is the maximum element. So first of all, this case, if the size of the array is 1, then you have to return 1. So we'll simply check this one. If n is equal to 1, so in that case, we return simply 1, right? And now we are sure that the size number of elements in the array is greater than or equal greater than 1, right? That means two elements exist. So we can simply check if AR of n minus 1 is equal to AR of n minus 2. And if that is the case, then means we have more than one occurrence of maximum element. So we'll return 0. Otherwise, we'll return 1. So yeah, let me try to submit this. Accepted, right? And the time complexity, yeah, the time complexity is n log n because we are sorting the entire array. So time complexity is n log n and the space complexity is constant. We are not using any extra space. It's actually auxiliary space complexity is constant. And inside in space complexity, the space taken by input is also considered, but in auxiliary space complexity, the space taken by the input would not be considered. So hope this problem is clear to everyone. Then the next problem. Another easy level problem. So you have a string named order consisting of two types of tiffin, 1 and 0. So basically given a string named as order and the elements, the characters are only 1 and 0 and it is of length n. All right. Yeah. So there are also a queue of any students waiting in a line to collect the tiffin of their preference. So every student has some preference, either 0 or 1. And if a student at the front of the queue get the tiffin on his choice from the order, he collect that tiffin and leave the queue. Otherwise, he rejoin the queue at the back. And our task is to calculate the number of students who do not get the tiffin of their preference. So see, every student is collecting tiffin, and if the tiffin of its preference is not present, then he join the queue at the end, right? So basically, students were not removing. And the important thing to note here, the preference of the student is also given in the form of string named as students. So basically, two strings are given. First order, right, 0 and 1. Then students 0 and 1. The ith element of order will represent the ith character of tiffin and then represent basically the ith tiffin and ith element ith character of this student string represent the preference of the ith student, either 0 or 1. And we need to report the total number of students who do not get the tiffin of their choice. And first student is standing at the front of the queue and the second student is standing after the first student and so on. So for the first example, 0 and 1. So the first student take the first tiffin, the second student will take the second tiffin, right? So the total number of students who do not get their preference tiffin is 0. Every student gets their tiffin according to their preference. So in that case, the answer is 0. For the second sample input, order is one tiffin of yeah, one tiffin of type 1 and one student of type 0. So in that case, this student whose preference is 0 cannot collect this tiffin because it is of type 1. So in that case, one student who do not get the tiffin as per his preference. So that's why the answer is 1. So hope the problem statement is clear to everyone. So yeah, how we can solve this problem? So there are some zeros, then 1, then again 0, then again 1, then again 0. So let's say this is our order string, then student string would be of same length. So 1, 0, 0, then 1, 1, 0, 0, and something like this, right? And both would be of same length then. So how we can solve this problem? Very easy and yeah, very simple reasoning. We'll first find the number of required one. So we'll first find required one, required type, required tiffin of type 1, right? And how we can find this thing? So this is nothing but summation of number of characters in student starting from I is equal to 0 to n minus 1, zero based indexing. The number of characters in the student string which is equal to 1, right? So student of I equal to 1, and this would return you a boolean value. If the ith character is 1, then boolean value is 1. So that's why adding 1 in the variable required one. Then we'll find the required 0 using the same thing, required 0, same formula. I is equal to 0 to n minus 1, summation of all the characters which is equal to 0. So student of I is equal to 0. So this is an boolean expression, either true or false, and if the ith character is 0, then it returns true, and we are adding 1. True means 1, we are adding 1 to the variable required 0, right? And now we know required 1 and required 0. In the same way, we will calculate how many ones and how many zeros we have in this order. So then we'll find have 1, or basically we can say, let's say a tiffin of type 1. And how we can find this thing? So this time we need to iterate over this order string. So again, I to 0, and order of I is equal to 1. Number of characters which is equal to 1 in the order string. And the tiffin of type 0 would be equal to number of characters in the order string which is equal to 0, right? Now we know the required one, we know how many tiffins we have. Now our answer would be equal to max of 0, max of 0 comma required one and minus have one. So required one and tiffin one. And why I'm taking max with 0? So let me tell you the reason. So there might be a case when tiffin the number of tiffins with character 1 is greater than the number of required one. So in that case, the student whose preference is 1, the number of student whose preference is 1 and not getting their preference is 0, right? But this value is negative. So if you do not do maximum with 0, then it would be, then you are adding maximum to your answer. Or let me give you some example. So let's say order is equal to 1, 1, 1, and required, okay, not required, but let's say student is equal to 1, 1, 0. So see, this time tiffin, how many tiffins of type 1 we have? 3. And how many required? Only 2 required, right? We require to have 3. So 2 minus 3, and then I'm taking maximum with 0, right? That means we have an extra tiffin than the required. So 2 minus 3, which is equal to minus 1. So maximum of 0 comma minus 1, which is equal to 0, right? So we are adding 0 to our answer. So hope you get the reason why I'm taking maximum with 0. Then similarly plus maximum of 0 comma required 0 minus tiffin with type 0. The same reason why I'm taking maximum with 0, right? So hope the problem statement is clear to everyone. Now if I show you the implementation here, so this first one denotes the tiffin of type 1, then the first 0 will denote the tiffin of type 0, then second one required 1, then required 0. Then calculating calculating first one and first 0, then required 1 and required 0, then our answer would be equal to 0, maximum of 0 comma required 1 minus tiffin of type 1, then again required 0 minus tiffin of type 0, and again taking the maximum, as there might be a case when the first 0, the tiffin of type 0 is greater than the tiffin of type 0 required. So if I try to submit this, accepted, right? The time complexity is linear, and the space complexity is also linear. So the time complexity is linear, space complexity, auxiliary space complexity is constant. We are not using any extra space. So hope it is clear to everyone. All right, so the last problem. Just allow me 1 minute. Which one? Not this one. Maybe this one. Yeah, let's just go with this one. So the minimum weight problem. So Geek has n boxes weighing 1 kg, 2 kg, so on till n kg, and our task is to form two set of boxes such that every box should belong to exactly every box out of these n boxes should belong to exactly one set, right? So basically we have to put every box in one of the two sets, and there should be at least one box in each set. While making the set, we have to must remember of these two rules. The first one, every box of the first set should have weight less than every box of the second set, and the absolute difference in the total weight of both the set must be minimum possible, right? So and we need to return that minimum possible absolute difference. So let's see how we can solve this problem. So let me explain you this test case for n is equal to 6. So n is equal to 6, right? So what does it mean? We have one box of 1 kg second box of 2 kg, third box of 3 kg, fourth box of 4 kg, fifth box of 5 kg, and sixth box of 6 kgs, right? And we need to put these boxes into two set. So let's say set 1 and set 2. The first condition, every set should have at least one box, right? And the second condition is that the weight of the boxes in the first set must be less than weight of every box in the second set, right? That means you have to partition these boxes into two set, and that is the only way which satisfy the first condition. So this one, this is the only way which satisfy the first condition, that every box of the first set would should weight weigh less than every box of the second set. So yeah, we have to partition this thing, right? So which partition will give you the minimum result? We have to return that minimum result. Minimum absolute difference of sum of the boxes of set 1 minus sum of the boxes of set 2, right? So what is the best way to partition it? So the best way to partition this thing from here, I guess from here, if I'm not wrong, right? So assign first four boxes to set 1, then the next two boxes to set 0. Okay, set 2, right? Now the maximum, now the absolute difference, sum of the boxes of set 1, which is 1, 1 plus 2 plus 3 plus 4, which is equal to, if I'm not wrong, then it is 10. Then here it is 5 plus 5 plus 6, which is equal to 11, right? And you have to return the absolute difference, minimum absolute difference. So 10 minus 11, which is equal to 1, right? And this is the minimum absolute difference that you can achieve. So minimum answer. So yeah, let me just quickly check. So yes, the answer is 1. Set 1 is having all the first four boxes, then the set 2 is having all the other two boxes, right? So I guess the problem statement is clear to everyone. Now how we can solve this problem? So one way could be start iterating from 1 to n, right? Start iterating from 1 to n and keep track of the boxes which are in the left along with their weight, and assign those boxes to set 1 and the remaining boxes to set 2, and then find the absolute difference, and then return the absolute difference after iterating over all the values from 1 to n minus 1. And why I'm saying n minus 1? Because every set should have at least one box, right? But that would take much time and it is very slow solution. You have to do something very fast, as the value of n can be up to 10 power 9. So this solution would not pass. So n can be up to 10 power 9. So the value of n can be up to 10 power 9. So this solution would give you TLE. You have to do something better, right? And what something better we can do? So the idea here is to use a binary search. And why binary search? As you can, if you can achieve this difference. So first of all, let's see what we want. So if I draw a number line mm, here, so 1, 2, 3, 4, 5, 6, and so on till n, right? So what we want? We want to part to divide this number line, right? Such that the sum on the left side and sum of on the right side is as close as possible, because we are returning the absolute difference, right? So the values, if the values are very close, then their absolute difference are also minimum. If the values are close enough, then the absolute difference are also will get minimized. So the idea here is to use a binary search, right? So we'll iterate. Okay, every time we'll find mid, and initially our search space is this entire thing. Low is equal to 1, and yeah, and high is equal to n, right? and then we'll simply apply a binary search for the mid. And if the values, see, if the absolute difference, if this sum is greater than, so let's say sum in left, sum left, and the remaining sum on the right. So sum right. If sum left is greater, if they are absolute difference, see, if the sum left is greater than, so let me write a condition here. If sum left is greater than sum right, so in that case, what I will do, I will move up my low pointer to mid plus one, right? That means we'll partition the array next time somewhere at here. We want these value to be as close as possible. We want some right and some left to be as close as possible. So that's why in this case moving low pointer to the mid plus one, and else part what I will do, I will move high pointer. So high is equal to mid minus one, and this is the entire solution. So let me just quickly show you the implementation. So the total sum, see, the sum of first n natural numbers is equal to n plus n multiplied by n plus 1 by 2, and make sure to keep care of this data type to avoid any overflow, because the constraints are very high, 10 power 9. So make sure to use long. Then I am storing this total sum as answer, then low and high. Initially we have this entire search space from 1 to n, then simply using a binary search finding the mid, then left sum would be equal to this one, right? The sum of first mid natural number, which is equal to mid into mid plus 1 divided by 2, and if it is greater than the remaining sum, then what I will do, I will shrink the right pointer, otherwise the left pointer, and then if the left sum not equal to 0, because the second condition, every set should have, okay, this one. Yeah, this one. Every set should have at least one box. So if the left sum is equal to 0, that means set 1 is not having any box. So that is an invalid configuration. So we do not, so we will break this loop, right? Otherwise we'll check if left sum not equal to total sum, right? This is the another condition. If left sum is equal to total sum, then that means all these all the boxes has been assigned to set 1. So this is another invalid configuration. So that's why checking these two things and then updating the answer with the minimum of answer comma the current absolute difference. The left sum and the right sum would be equal to total sum minus left sum. This is the entire solution. Then we are returning this answer. So let me try to submit this thing. Accepted, right? And with the time complexity n log n, because we are using a binary search, dividing search space every time by 2. And the time complexity, let me write it here, is log of n base 2. Right, so this is the entire solution for today's contest. Hope you guys have learned something new. In case if you have learned something new, then please do hit the like button and share your feedbacks on the comment. Have a good day.